Hello dear students, today we discuss about the another type of heterogeneous mixture, and that another type of heterogeneous mixture is colloid. So do you remember the activity which we have discussed in our earlier lecture, where we have taken the three beakers. In first beaker we have added copper sulfate, crystals of copper sulfate in water. In second one you have added some drop of ink or milk in water, and in third one you have added what? You have added sand in water. So in first case where you were getting a clear transparent colored mixture, because copper sulfate is blue in color, so you were getting clear transparent colored mixture, and that clear transparent homogeneous colored mixture, it was what? It was solution. On the other hand, when you have added sand in water, you were getting a heterogeneous mixture where the particles of components were easily identifiable from each other, and now the particles were also easily filterable by simple filtration, and this mixture that we got here was suspension. And if you look at the mixture 2, where you have added ink or milk in water, then what happened? The mixture was having some properties similar to that of solution and some properties to that of suspension. It was not as clear and transparent as the solution, neither it was showing you the clear distinct particles as in case of suspension. Also, the particles were not separable by the simple process of filtration, but this mixture showed you the property of scattering the beam of light. So here the second mixture, that is ink in water or milk in water, is showing you the properties that are in between that of solution and suspension. And the mixture which we got here is what? This mixture is known as colloid, right? So today we will be discussing some more details about this type of mixture that is known as colloid. So what is a colloid? If we define the colloid, what is a colloid? Colloid, you can say, is a heterogeneous mixture. Colloid is a heterogeneous mixture which appears to be homogeneous. So a mixture which by nature itself is heterogeneous, but it gives you the appearance of a homogeneous mixture, that mixture is known as colloid, right? So if we look at the properties of colloid, what properties do you observe here is, first of all, it is heterogeneous. Second one, if you look here at the particle size, here the particle size is in between true solution and suspension. So here the particle size is between 1 to 1000 nanometer. If you remember, the particle size in true solution was less than 1 nanometer. In suspension it was more than 1000 nanometer. So in colloids it is in between 1 to 1000 nanometer, right? Another property in colloids are that colloids are stable. Stable means they do not settle down when left undisturbed. As the colloidal particles are light enough, they are not influenced strongly by the force of gravity, and that's why the particles don't settle down, and we say that colloids are stable. Clear? One more property in colloids which we observe here is they are not filtered by ordinary filter paper, but particles can be separated by using semi-permeable membrane or by centrifugation, right? So you cannot separate the particles of colloid by simple filter paper or by using an ordinary filter paper as we have done in case of suspension. But the particles of colloid can be separated by using the special type of membrane which is known as semi-permeable membrane. Semi-permeable membrane is a membrane where the particle size is, where the pore size is so small that the particles of colloid cannot pass through the solution, through the membrane. So either they can be separated by using a semi-permeable membrane or they can be separated by using the process known as centrifugation. So what is centrifugation? The details of centrifugation we'll be discussing in the later on lectures, but right now we can say it is a process in which a mixture is made to rotate at a very high speed so that the heavier particles they settle down at the bottom and the lighter particles they come to the surface. In our daily life also we use this phenomena of centrifugation at number of places that we'll be discussing later on. And one more very important property which we observe in case of colloids is that they scatter the beam of light passing through colloid. So if we pass a beam of light through colloidal mixture, these colloidal particles they scatter the beam of light, and this phenomenon of scattering the beam of light is known as what? It is known as Tyndall effect, right? So if we have a colloidal mixture in a container and if we pass a beam of light through this colloidal mixture, then what happens when the light enters the mixture? The path of light becomes visible as well as it is broadened, right? So you can see the particles of colloid shining brightly here, right? So this scattering of beam of light by colloidal particles is known as Tyndall effect. And this bright shiny path of light which is in the form of a cone, the path is becoming conical and this cone here is known as Tyndall cone. Clear? So there are so many examples from our daily life that show you the phenomena of Tyndall effect. For example, if you are sitting in a very dark room, all the doors and windows are closed, all lights are off. In that dark room, if from some a small hole or a slit, light is entering, then you will see that the path of light is becoming broadened, and you can see the shining bright dust particles or suspended particles in air. So this scattering is because of the scattering caused by the particles, colloidal particles present in air, and the phenomena here is known as Tyndall effect, right? One more example you can think about, if you use a torch or if you observe at the headlights of the vehicle, maybe your cars or scooters, then what happens? The opening of these lights is small, right? But on the road, as it moves ahead, the path of the light is becoming wider, because and slowly this light that covers all the path, all the road, and this phenomena is again, this process is again because of the phenomena known as Tyndall effect, right? So many examples of Tyndall effect you can observe in your daily life if you focus on them. And as we have discussed earlier, like solution has got two components, solute and solvent. Similarly, there are two components in a colloid also, but this time the components of colloids are known as dispersed phase and dispersion medium. So if we look at the components of colloid, so there are two components of colloid. One is dispersed phase and the another one is dispersion medium. So what is dispersed phase? Dispersed phase, you can say it is solute-like component of the colloid. The component which is dispersed, which is present in a small amount, is dispersed phase. And dispersion medium is what? It is, you can say, a solvent-like component, the large component, and which is in which the dispersed phase has been mixed. That is known as dispersion medium. And depending upon the states of the physical states of the dispersed phase and dispersion medium, you can have different types of colloids. So let's have a look at the different types of colloids. Here we take the dispersed phase. Here we take the dispersion medium. Then we can have here the type of colloid and its example. So first case, when dispersed phase is liquid, dispersion medium is a gas. It is a case of liquid and gas colloid, and this colloid is known as aerosol. For example, we can talk about here about fog, right? Another one is when the dispersed phase is solid and dispersion medium is gas, then it is also known as aerosol, and the example here is the smoke, or you can say the exhaust from chimneys. Then another one, if the dispersed phase is gas, dispersion medium is liquid, then it is known as foam. For example, here we can take the case of shaving creams. Then another one here is when dispersed phase is liquid, dispersion medium is also liquid, then it is known as emulsion. For example, milk is a case of an emulsion milk, and another one here is when the dispersed phase is solid and the dispersion medium is again liquid, and here the type of colloid is known as sol. For example, here you can take the case of mud, right? Then we can have the dispersed phase to be gas, dispersion medium as solid. The type of colloid here is also known as foam. And now the example here are rubber, sponges, etc. Clear? Then you can take when the dispersed phase is liquid and the dispersion medium is solid. This type of colloid is known as gel. For example, butter, right? And then another one where the dispersed phase is solid, dispersion medium is also solid, then the colloid is known as solid sol. And for example, here we can take the different colored gemstones are the examples of solid sols, where both the dispersed phase and dispersion medium are solids, right? So that is all about the colloids, the different types of colloids, their components and the properties of colloids. In our next lecture, we will be discussing about the various methods that can be used for separating the various components of colloids of the mixtures, and there are various methods. Which method will be used, that depends upon nature of component of a mixture, right? So that we'll be discussing in our next lecture. Goodbye till then, have a nice time.